Hey guys, welcome to the Biomechanics 1 video series looking at forces in this particular lecture. Before we get to that, we'll have to unpack a couple of factors around just how to resolve the different sides of a triangle, because we have to get comfortable with solving triangles in order to unpack forces a little bit more. So the key aspect, if I have a right-angled triangle, let's just say it looks something like this, and it tends to act at right angles. I normally provide some kind of angle, right? So let's just call that angle for now theta. It just represents any arbitrary angle. And I have three sides to this triangle. The first point that you'd normally want to do is kind of subdivide your triangle by labeling it. Typically the side that is opposite the angle is literally just called the opposite side. The side that is kind of sitting next to the angle is called the adjacent side. And the side that is opposite this right angled symbol is the hypotenuse. It's also the longest side of any given triangle. So I have these three sides, and there's some calculations that I can run that will allow me to find the length of each of these sides. One of the first ones, without using the angle, is just called the Pythagorean Theorem. It's probably something that you guys have seen time and time again. In essence, it states that c squared is equal to a squared plus b squared. And you might be asking, well, where are these sides coming from? Well, I can label any of these sides a, b, and c, with the exception that c has to be the longest side. Alright, so it's in essence saying that the length of the longest side squared is going to be equal to a squared and b squared. I could also write this as the length of the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Doesn't really matter, right? They all boil down to the same thing. So I could rearrange this equation to make any one of these letters the subject of the formula. So this one's saying that c is the subject of the formula if I have a and b. What if I don't have a and b and I get given c and a? So I'm trying to solve for b. So if I'm trying to make b the subject of the formula, it would look something like that. If I only have c and b, then I can make a the subject of the formula, and the formula would look like this. Okay, so I can rearrange it whichever way I want to, depending on which sides I'm ultimately given and the side that I'm looking for. Okay, let's say I only have one side and I have an angle. That means I have to use a slightly different technique in order to do that. And the concepts of sine, cos, and tan become important. So the sine of any given angle is equal to the ratio of the opposite side divided by the hypotenuse. The cosine of any given angle is equal to the ratio of the adjacent side divided by the hypotenuse, and the ratio and tan of any given angle is equal to the ratio of the opposite divided by the adjacent. So an easy way to remember what is divided by what is the mnemonic phrase SOHCAHTOA. Right, you guys might have seen this somewhere before. In essence, it's saying that sine is equal to the opposite divided by the hypotenuse, cosine is equal to the adjacent divided by the hypotenuse, and tan is equal to the opposite divided by the adjacent. Okay, so that's probably the easiest way to try and remember which of these ratios are divided by what. Okay, so I'll normally sit with a problem that looks something along these lines, that I get given the length of one side of the triangle, and I'm typically asked to find the length of the other two sides. So The units here can literally be anything because the principles will be the same. So it can be given in newtons, I could give it in meters per second, I could give it in centimeters or just in seconds. It really doesn't matter. The units here are arbitrary, right? Whatever units I use here will be the units that I solve for on these sides. This we'll just call x and this we'll just call y, because that's just the way we do it, right? And I get given some angle, right? In this case, I might say that the angle is equal to, say, 30 degrees. So how would I solve for this length of x? Well, the question is that you always have to ask yourself is, what are the lengths that I have? And also what length am I solving for? Because that's going to help you decide which one of these sine, cos, and tan you will ultimately need in order to solve for this triangle. Well, in this case, I'm trying to solve for x, right? So what I would need to do is ask myself, what are the lengths that I have? Okay, in this particular triangle, I have this 100 newtons, which is the hypotenuse. So I have the hypotenuse, which is equal to 100 newtons. I have the angle, which is equal to 30 degrees, and the side of the triangle that I'm looking for is the adjacent side. That's the one I don't know. Okay, so which one of these three, equation 1, 2, or 3, has the hypotenuse in it? So it's over here, and it's over here, and it's not in this one. So tan is a no-go for this particular equation. So it must be sine or cos. Well, the side that I'm looking for, which is going to provide the answer, is the adjacent side. So I need an equation that has the hypotenuse, the angle, and the adjacent side. So if I look at this, cosine has adjacent and the hypotenuse, so it meets all the criteria, and it's the one that I would need to use in order to solve for this adjacent side. So let's just rewrite it here, and it says that the cosine of an angle is equal to the adjacent divided by the hypotenuse. Since I'm trying to solve for the adjacent, I can kind of multiply this out, which would make the formula look like this. The hypotenuse times the cosine of the angle is going to be equal to the adjacent side. Well, then it's just a matter of plugging in the values that I already have. That's 100 times the cosine of 30 will tell me what this adjacent side is, which, if I do it on the calculator, 100 times the cosine of 30 gives me 86.6. And remember, your answer is in newtons, so it should be 86.6 newtons. Nice, so that's the one side done. Let's try the other side. In this case, I'm looking for the opposite side. So again, what do I have? Still the same triangle, so I still have the hypotenuse, which is 100 newtons. I still have the same angle, which is 30 degrees, and in this case I'm looking for the opposite, so I'm sure you guys get the drift, right? So which one of these three options has the angle? They all have the angle. Two of them have the hypotenuse, and only one of them has the opposite, so in this case the sine function is the one that I would have to ultimately use. Alright, so if I just had to rewrite this, I would say that the sine of the angle is equal to the opposite divided by the hypotenuse, which I could then write as the sine of 30 is equal to the opposite divided by 100, Well, I can bring the 100 up to that side, so that would look like this. Sine of 30 is going to be equal to the opposite, which is equal to 100 times the sine of 30 is going to be 50. Okay. So that equals 50 newtons. Right? Let's just write that in here. That's equal to 50. And this we calculated was equal to 86.6 newtons. Right? What I could have done in this example also is, once I had the two sides, let me just try and redraw this for a second. Once I had calculated the one side already, I could have just used Pythagoras. So once I calculated that was 100, and I calculated that this was 86.6, I'm still looking for that side. Well, Pythagoras tells me that I could use this law, or this rule, this theorem, in order to solve for the unknown side, right? We know that this is a right angled triangle. So I could have said that the length of the hypotenuse squared is equal to the opposite squared minus, plus the adjacent squared. Right? In this case, I'm looking for the opposite. So we said that the opposite squared is equal to the hypotenuse squared minus the adjacent squared. So I can just plug my values in, which is 100 squared minus 86.6 squared. And since this is squared, I would square root both sides to get the opposite on its own. And you would find, if you do that in the calculator, you should sit with the same answer. Let's just double check that. 100 squared minus 86.6 squared. And then I'll take the square root of that, and I sit with 50. And it's got a couple of decimal places. It looks something like this, where it's 50.004 newtons. But when we round it off to the nearest number, that's pretty much 50, right on the dot. Okay, so either way we sit at the same point. The maths is all adding up, and that's kind of how you would solve the three sides of a triangle. There's a couple of different options. I guess the last part that I wanted to show you guys is to solve for this angle. So let's say I was given this particular triangle, and I've got these two sides. I could also solve for this angle using the same principles of SOHCAHTOA, right? In this case, what you would want to do is to say, well, what are the sides that I have again, and what is the angle that I need to ultimately solve for? So again, I have the hypotenuse, which is 100 newtons. I have the adjacent, which is equal to 86.6 newtons. And in this case, swapping it around a bit, what is the angle? So we'll go through the exact same process. Which of these three options has all the things that I'm looking for? So I need one that has the hypotenuse, so tick for sine and tick for cosine. I need one that has adjacent as well, so that's a no for sine, and that's definitely a tick for cosine. So cosine is the one that I would use. It says that the cosine of an angle is equal to the adjacent divided by the hypotenuse, right? So when you plug this into your calculator, there's just something that you have to do, which I'll show you guys now. Adjacent is equal to 86.6 divided by 100, right, which means that the cosine of that angle is equal to 0.866. So in order to get this angle by itself, you need this inverse cosine function button on your calculator multiplied by this 0.866, and the angle that it spits out should be 30 degrees, right? Because we got these sides from early calculations using this angle of 30. So working backwards, we should get the same angle. So when you do that on your calculator and you say inverse cosine of 0.866, Again, you'll get a couple of decimal places. It ends up being 30.000029, but you can see that's pretty much on 30, right? So I need you guys to go practice that. There should be a couple of examples in the biomechanics manual for you guys. Again, the principles will always be the same. There's always the same methodology for solving for the opposite and for the adjacent sides. In 90% of cases, you're going to be given what the longest side is and the angle that it tends to make with the horizontal. Alright, so if there's any questions, drop me an email and we can always go through it in my office. Best of luck. Thanks, guys.